So I was a huge low carb fan for a while. And then I'm like, oh, wow, maybe this paleo thing is, where it's at, because I realized that, oh, when you eat less processed foods, you eat more protein and fiber, you have higher, satiety, and you don't eat as much. And so I kind of fell through the low carb, paleo, keto, carnivore, wormhole that so many people have fallen through. But then I kind of realized, oh, wait a second. The low fat people have just as many success stories. And anyone who just intentionally lowers the fat percentage of their diet is going to immediately have a higher protein percentage, higher satiety per calorie. They're going to have weight loss. Also, in fact, when you equate these low carb and low fat groups, you get the same outcomes. And then I realized, that's only when protein percent is matched. And then I started going down this rabbit hole of protein percentage. And then I became familiar with the research of Doctors Raubenheimer and Simpson, these famous guys in Australia who discovered the protein leverage phenomenon. Humans and many animals basically eat until they get enough protein, and only then do they stop eating. And that's why protein percentage is one of the biggest drivers of ad lib energy intake. Hunter-gatherer world macronutrient average for hunter-gatherers is about 33% of calories from protein. But the standard American diet is all the way down at about 12.5% protein. And then this obesogenic rat chow is at 10% protein. And if you look at things like the databases of people who've successfully lost weight and kept it off, the one thing they have in common is they've managed to get protein to about 20% of calories. And if you look at studies where you take pre-diabetics and force them to eat 30% of calories from protein, you completely cure 100% of all pre-diabetes. And then you look at elite bodybuilders who are usually, living at 35% protein or maybe even 40% protein from calories. And it turns out that just protein percent of calories is probably the single biggest factor when it comes to how many calories you're going to eat. You can do low carb wrong by just eating tons of fat, because I have so many patients who have stalled out on ketogenic diets. Mm-hmm. And if keto was really the answer to just being thin and healthy, everybody would be thin and healthy, right? The whole keto community would be like amazing. Everyone would be blown away. It just really doesn't happen. Like every single person who goes on keto loses 20 pounds instantly, loves it, and boom, stalls out hard and just stays there forever. And the reason for that is because basically you increase your protein percentage and your satiety per calorie when you eliminate refined carbs. But then if the protein percentage is too low or not improved from there, you're basically going to still overeat calories from fat. Your macadamia nuts and your cheese and your butter, and you're going to get thinner and then plateau out when your protein percent doesn't change. And so the way you get past that is to crank up the protein percentage, eat leaner proteins, get rid of really high fat foods and refined fats like, butter and heavy cream and oil and high fat dairy and all this stuff. And then you can actually bust through this sort of keto plateau. But you can do the same thing on a low fat diet. And if you're really smart, you're doing both, like someone like yourself, like a bodybuilder, is basically just as low carb and low fat as you can get at the same time. The type of vegetarian that I was raised is sort of a religious vegetarian, where it's just a sin to kill animals, eat them. And so if you just basically eliminate high quality animal foods, the protein percent of your diet actually goes significantly down, because all of your plant foods on average have a lower protein percent than all of your animal foods on average. So it's actually like a slight downgrade to just decide I'm going to religiously avoid animal products. Well, okay, there is some magic there, and that's when it comes to energy density. So there are two huge drivers of ad lib caloric intake. The first one is protein percentage. That's the biggest one. That's the most important one. That's probably the biggest lever anyone can pull. The second one is energy density of the diet. And basically, the lower the energy density of your diet, the less calories you're going to automatically eat, the less ad lib calories you're going to eat. So what happens when you go on like a whole foods plant-based diet is the energy density of your diet just immediately goes way down. Like you look at the Kevin Hall study last year, where he put people on like a high-fat keto group and then a low-fat plant-based group. The keto group was animal, and the low-fat group was plant-based, and the low-fat plant-based group ate 700 calories a day less automatically with unlimited access to food. But it turns out they had half the energy density of the overall diet compared to the higher-fat, lower-carb, keto, animal-based side. So if you're just going on a whole plant food diet, you're cutting your energy density maybe in half, which is a huge driver. Now, you can actually have the best of both worlds where you're eating high quality animal proteins, but you're getting the leanest ones you can and ones that have a super low energy density as well, like egg whites, amazingly low energy density. The egg whites are ridiculously awesome because it has, it's 100% protein and a super low energy density. You can just eat pounds of this stuff for almost no calories. Right. So if you're really smart, you're marrying those two together. But I would say that anyone who goes plant-based, instant win to a certain degree because you're cutting energy density in half.
Yeah, so I always joke that I'm 50% carnivore and 50% vegan. So the idea is like really energy dense.
Introduction to all this was, basically like Atkins way back in the day. And I had patients who just said, oh, hey, I just stopped eating carbs and boom, I lost 30 pounds and instantly cured my diabetes and my blood pressure's gone. I threw all my meds in the trash. And this just blew me away. And I saw this over and over. People who if you just tell people don't eat carbs, there's so much junk that they're cutting out that it's kind of like this instant win. But it's a win to a point. And then, like I said, if you're replacing these carbs with high energy density, high fat, low protein percent stuff, you're going to stall out really hard and go nowhere. And that's what happens to so many people on a low carb diet. But so then for me, like paleo came along and it was a little bit more nuanced. It was like, okay, you can eat some carbs, just don't eat these processed refined carbs in this certain category. And what it turns out is that this category is foods that are super low in protein percent and super low in minerals and energy density, in nutrient density. So you're basically eliminating a lot of high energy density foods and replacing them with higher nutrient density, lower energy density foods. And so paleo was like one rung on the ladder better than just low carb. I had to fall through all of these and research them all. And then finally I could zoom out and see the whole big picture and what all the drivers are. And the reason every diet has a certain amount of success is because they're pulling the same levers: higher nutrient density, lower energy density, higher protein percentage. These are all like kind of different sides of the same coin. So anything you can do to increase protein percent, increase nutrient density, lower energy density, basically lower refined carbs, lower refined fats, processed carbs and fats, you're going to win. And so all of these diet religions are doing the same thing, a little bit of different parts of all of these things. And once you kind of get the big picture, you can kind of zoom out and pick and choose, and you don't have to be religious, and you get to be agnostic with your diet, which is kind of my goal. So for me, the very most important concept of all is satiety per calorie, right? It's the most magical and important concept of all. And it's definitely evidence-based as to what improves satiety per calorie. There's about 9 things that are proven in the medical literature, scientific fact, to improve satiety per calorie. First one is increasing protein percentage. Instantly improves satiety per calorie. Second one is fiber, grams of fiber per 1,000 calories. You increase fiber, you will improve satiety per calorie. The third one is a reduction in refined and high glycemic carbohydrates. So this is an evidence-based phenomenon. If people eat just like juice and toast and cereal for breakfast, they're literally going to eat 300 more calories during the day. If you reduce refined and high glycemic carbs, you will eat fewer calories. The next one is actually eating less fat. So unfortunately, the more fat you eat, the fatter you're going to be. It's passive overconsumption, and it's a scientific evidence-based fact that a reduction in fat will actually lead to eating fewer calories. In fact, you can take any animal and just pour fat on top of their usual food, and they'll just immediately passively overconsume and get fatter. Lower fat for satiety per calorie. Okay. And this is really, really important because all the keto people are like, well, that's stupid. When I eat butter and bacon, I get tons of satiety. Like I eat a stick of butter, I'm not hungry for 50 years. Fat's the best for satiety. And what they're not doing is dividing that by calories and coming up with satiety per calorie. So yes, but eating a stick of butter gives you crap ton of satiety, or you won't be hungry forever. But that's 1 trillion calories. So satiety per calorie is actually garbage, and you'd be better off just eating some sort of lean protein. Lower energy density, lower processing, less processed foods. The thermic effect is higher. You have to process it yourself. It burns more calories. You extract less calories from it. We have studies where you just feed peanuts to rats versus peanut butter, and they get fatter on the peanut butter. So protein, fiber, water, higher. Energy density, carbs, fats, processing, alcohol, you want all those lower. Nutrient density, minerals and micronutrients, the higher those are, the higher satiety calorie. So yeah, these definite themes that are all evidence-based, that all improve satiety per calorie and all make people more successful with a diet. And the idea is you do a little bit of all of these all at the same time. And you can't go too extreme with any of them. You can't eat 100% protein forever, and you can't eat 0% fat, and you can't never eat any carbs. So you try to just take your existing diet and tweak all these levers up a little bit sustainably. A little higher protein percent, a little higher fiber, a little higher water, less processed, less carb, less fat, less energy density, less alcohol, more micronutrients. And you just tweak all of these as much as you can stand where it's sustainable. And that's honestly this whole PE diet concept that I'm talking about. It's self-limiting. Like no one can eat too much protein. Like you can just give anyone, 10 pounds of skinless chicken breast and tell them to eat too much protein. Go for it. You physically can't do it. So eating too much protein isn't really a thing. That's not like a medical condition. That's not a diagnosable problem. To be fair, we don't have any studies in humans or animals where they're fed 100% of calories from protein forever. These explorers who in the middle of winter only had super lean, starving deer and rabbits to eat, and their dietary protein percent was, 90+%. They get very, very thin and very nauseated and very sick. For any free living human who has access to non-protein energy macronutrients like carbs or fats, you will basically eventually just eat less protein and eat more carbs and fats automatically, which is what any animal will do. So you can't make yourself eat too much protein. Your body will upregulate or downregulate the production of some of these enzymes and factors that digest different foods. So you really never want to take your whole diet and just completely reverse it and flip it on its head and change it 100%, because you're probably going to struggle to digest X or Y, and you want to make more gradual changes. So you can take someone who doesn't have a lot of digestive enzymes for protein, for example, and just progressively overload them and give them higher and higher amounts. You will adapt to fit the diet that you're given. That's what humans are this amazing survival machine, and we basically can live on any food, anywhere, anytime. Well, so kids seem to be fairly similar to adults. They actually, 1 gram per pound seems to work, like honestly, all the way from infancy on up. And there doesn't seem to be a downside to higher protein percentages. So it's not like, okay, adults should really try to tweak their protein percent up to have higher satiety per calorie and be thinner, but don't do that to kids because it's dangerous. No, that's not really a thing. So there's no particular limitation. Obviously the accepted macronutrient range for humans in general is 10 to 35%. And these are kind of pulled out of thin air and arbitrary, but you wouldn't want to go way beyond those for any human, including kids. To be fair, anytime you eat a protein-containing food, all the proteins are just broken down into the exact same amino acids. So you're going to get the same amino acids from plant foods or animal foods. The difference is in the percentage of those amino acids, right? So when you eat an animal, you've got the right spectrum of aminos to build an animal. And when you eat a plant, you've got the right spectrum of aminos to build a plant. And so, like, for example, animal muscular hypertrophy in humans, leucine seems to be a huge driver of that. And when you eat animal protein, it's about 10% leucine on average. But your plant protein is like 6% leucine on average. Basically, animal protein is a little better at building animals. You can get there with plant protein, but you might have to eat up to 1.5 times as much. Then there's also a fiber issue. A lot of plant proteins are bound up in fiber, and it's harder to extract them. So if you're really trying to scavenge all your protein from like broccoli, you're in a lot of trouble. Like, you'd have to eat enough broccoli to just die of a bowel blockage before you're going to get the same amount of protein that you just, get from a half chicken breast. So there are all these benefits to animal protein. It's way more digestible. It's way more accessible. It's got a higher leucine percentage and a better spectrum of aminos to build animals. But you can make plant protein work. And there are plenty of vegan bodybuilders who are doing it. But to be fair, they have to supplement a lot, and they are usually aiming a little higher on absolute grams of protein. I think the longest studies we have are at about a year at 2 grams per pound in one of Jose Antonio's study. And that was pretty long time to consume that much protein. I think your average person is just not going to comply with a study like that. But they basically picked bodybuilders who are already eating a crap ton of protein from whey shakes. And the difference between whey is when you consume your, bodybuilding whey that's very low carb and very low fat, it's just pure protein, right? Like, so your 30-gram scoop of whey powder is like 27 grams of protein with maybe 1 gram of fat and 1 gram of carbs, versus like when you eat a steak, it's 100 grams of steak is only 25 grams. Protein is extremely insulinogenic. Insulin goes way up from egg whites and fish and whey powder. But glucagon goes up as well. So your blood sugar doesn't change at all. That's the difference between, like, if you eat a donut, hugely insulinogenic, and glucagon goes down and your blood sugar goes way up. That doesn't happen with protein. So when you eat protein, insulin and glucagon go up together and your blood sugar stays flat as a pancake. So you can eat like 5 pounds of turkey at Thanksgiving dinner and your glucometer will just be flat as a pancake. So you actually don't care that your insulin went up because your glucagon went up as well. And the ratio doesn't really change. Gluconeogenesis is demand driven, not supply driven. So you can eat, 1 trillion grams of protein, but you'll still only manufacture as much glucose as you need to keep your muscle glycogen topped off and to stay alive. Humans maybe make 70 grams of glucose or something a day. I kind of like eating fewer carbs and more protein and performing a little bit of gluconeogenesis because it's almost like metabolic exercise for your body, right? It's kind of like your body has to work a little harder just to stay alive. And so I kind of like that. I don't recommend people eat these 0 carbohydrate diets because, let's say you need 70 grams of glucose just to keep your brain and your red cells alive and all these cell types in your body that don't have mitochondria and that have to burn glucose for fuel. If you're eating no carbs at all, you're going to basically have to break down, 70 grams of protein just to make enough glucose to stay alive. And so it's a little bit protein wasting. Like to be honest, for the average person, just eating 100 grams of carbs a day is going to be somewhat protein sparing because this will spare that much protein that you don't have to use for gluconeogenesis. And so really a carbohydrate intake is on this U-shaped curve where, too high is like the 60% of calories that everybody eats in America, which is a nightmare. But then too low is like these 0 carb, keto, carnivore, hardcore things where you're basically not sparing protein, the protein you use to make glucose out of. And it's a little bit smarter to eat maybe 100 grams of carbs a day or more, another gram for every minute of high intensity exercise you do, which is glycolytic and burning glucose. So you're basically replacing at least the glucose you're burning with high intensity exercise and the glucose you need to stay alive and sparing that much protein.
These researchers saying how you can only absorb, digest, and assimilate this small amount of protein.
Yeah, that's basically not true. So there are plenty of people eating 1 meal a day and they're completely fine. If that was true, humans would have become extinct a long time ago. And we have all these animals, like a lion who eats a gazelle, once a week, and a cat that eats a mouse every other day. And obviously animals can eat protein in these boluses. And then you get this you get all sorts of pooling of the amino acids. There's this Blanknick bed that pull in your GI tract that pulls some aminos, and you have this increased amount of aminos in your bloodstream for, up to 24 hours afterwards. And so there are all these reasons why you can eat protein higher amounts less frequently, and it's very slow to digest. That's the other thing. There's this ileal break in your small intestine where the huger piece of protein you eat, the more it slows down your GI tract and kind of meters out the aminos. So honestly, I really don't worry about people who are just eating, maybe twice a day. Personally, I think shrinking it all the way down to once a day, it's a little hard to get enough protein in. And so meal frequency is on a U-shaped curve as well. And I think once a day or less is probably really far from optimal, but nobody needs to eat 12 times a day. And so, I like two meals and a snack a day or somewhere around there. Yeah, absolutely. Blood urea nitrogen, BUN. So anytime you get a basic metabolic panel or a comprehensive metabolic panel from your doctor, part of the kidney function is blood urea nitrogen. This is just basically an ammonia, like a protein breakdown factor that's in your blood that you're filtering out in your kidneys. And they established the normal range of blood urea nitrogen, not by looking at where humans should be, but just from everyone who goes to the lab. So if you take every trillion people who go to the lab and graph out all their BUNs on this little bell-shaped curve. You just put the upper and lower limits of normal at 2 standard deviations away from the mean on the high end and low end. Everybody on these super high protein diets are going to be way up here on the high end of blood-urea nitrogen, and it's going to be reported as high. And your doctor's going to be like, I don't know what's wrong. Maybe something's wrong with your kidneys. As long as your creatinine is fine and your glomerular filtration rate is fine, it kind of doesn't matter how high your BUN is. And we definitely see these higher and higher on people on higher and higher protein diets. It does seem to be harmless.
Do you support digestion with enzymes?
I really don't, but I am aware of the fact that some people, when they really up their protein, struggle with abdominal pain and digestion and all this stuff. And that's why I am a fan of slowly progressing things. And I find that most people, if they progress slowly, they usually don't have to go that route. I mean, there's always exceptions. I have patients, with chronic pancreatitis, and they're taking all sorts of pancreatic enzymes. They kind of have to do that. But the average person, if they're just slowly progressing, they can kind of adapt and get used to it and upregulate their production of certain digestive enzymes. Yeah, it's not age specific for me. I pretty much recommend everybody target a gram per pound of ideal body weight. And I really think that as you get older, it's more and more important to target that, and it's a bigger deal, and we do see anabolic resistance. It appears to be that the amount of protein available to trigger hypertrophy and anabolism, you need a higher threshold. So you literally have to eat more protein to get to the same threshold for anabolism.